Okay, so let's go ahead and take a look at these. The first one, again, what you need to do is always start off drawing your hill and across, and then put your little notch in the middle. And then we need to go from z is 0. So where is 0? Right here. And where is negative 2.14? Somewhere on the left. I don't care where. And then shade in between. Then find this area. You're going to do, what was it? Normal CDF. What's the z-score on the left? Negative 2.14. What's the right one? 0. And again, if you use the subtraction symbol here when you put it in the calculator, it's going to give you an error. You have to use that little parentheses minus sign that's right next to the enter sign to make it a negative number. That's how you make it a negative number. And what did you guys get for this one? 0.4838. Okay. I'll go with that. This is B. And again, draw your picture. Hill, line, spot in the middle. And then I need to figure out 0.29. Is that on the left or the right? It's on the right because it's positive. So somewhere on this right, we're going to put that in there. 0.29. And then we want the area to the right of it. So it's going to be over here. Okay? Good. So then I'm going to do, and then maybe I figure out, okay, so what's the z-score way over here? Infinity. Great. So I'm going to do normal CDF. What's my left z-score? So look at the shaded area. Look at the beginning of the shaded area. This is my beginning. Everybody see that? This is my end. So 0.29, comma, instead of infinity, pick any large number you want.
30.
30? Great. Perfect. What did you guys get? 3858? Fine. 3859? Good.
Wait, so where do you want the infinity? On the picture? Or
Yeah, yes, sure. I think it's good to have the
and then
infinity.
any number on the normal?
And then a normal CDF you could put either one. I'm good. If you want to put infinity here also, that's okay. I just want to make sure you guys have some sort of idea of what you might put into your calculator. I'm fine putting 30. Put in something large. I just have people use 999, but the problem with 999 is that people start putting in 0.999, and then that's not a large number. That's less than 1. So then I think if you just pick a large number, then I think it's easier for you to wrap your heads around and not make a mistake there. All right, and then this one. Again, put your notch in the middle. 1.09 is on the left or the right? On the right. And then this one is also on the right, but it should be bigger on the right, so make sure you give some space between them. Does not have to be to scale, I don't care about that, as long as you put it on the correct side. And don't have the don't have the bigger one to the left of the smaller one.
So because it's like 1.19 and 1.83, it doesn't have to be like
Right, it doesn't have to be. Whatever you want. I mean, theoretically, you might put it. Someone else might have said, "Well, I really feel like it should go. 109 should have gone there."
That's what I did.
Yeah, I don't care. If you can, you can. Totally, you can. If you didn't, I'm not going to dock you. I'm not worried about that. What I care about is that these are both positive, so they should be on this half. One of them should not be over here. Do you guys see what I'm saying? The other thing I care about is that this one's bigger than that one, so this one better be on the right and this one better be on the left. You better not have them flipped, because that would be another big error. But yeah, so as long as you put the negative ones on this side, positive ones on this side, and the bigger ones to the right of the smaller ones, then we're all good. That's as much as I need. And then this one's pretty straightforward, right? You're just going to do normal CDF. Of 1.09, comma 1.83, And what did you guys get? Alyssa, what did you get?
1042.
1042. Good. Everybody all right with all that? Perfect. So you guys do lab problem number 2. Take a minute, draw your picture, and sort that one out. Right below it, lab problem 2. The probability, find the following probability. Ooh, using the standard normal distribution. Normal distribution, that should tell you. Normal distribution, I better draw a hill. All right, so what did you guys get for your, what word did you put the first one? Do you guys need another minute, or are you guys all good with this?
On that side.
A minute? Yeah. So negative, right? So saying your z-score is between negative 1.43 and 0. So draw your picture, put your stuff into your picture, draw your lines and shade. So this is the bare minimum I need. I need this hill. I need something on the left, 1.43.
Are we going to get points deducted for bad hills?
No. You will not get points deducted for, you'll get points deducted for
No hills?
no shading, right? If you don't shade, and if you put them in obviously wrong spots. Like if you put negative 1.43 over here, then you'd be in trouble. And then, oh, also, put them below. I want them below, down here. I don't want them above, I want them down here. Because the above area is where we'll put areas later on when we need them. So it's just good to get in the habit of keeping them kind of uniform. And then 0 is right here.
Yes.
And then you got shaded in between. Make sure you shade. No shade, no points for that. And then you guys did normal CDF of negative 1.43, comma 0. And you got what? 4236? Okay, great. So again, the probability that z is between two numbers is the same thing as the probability that, from the area from here to here. Area from here to here, same thing as the probability your z-score is between these two scores. So this is another format you might see it in. So we're going to summarize this point. Edgar, go ahead and read.
Summarize one main point. Area under the curve equals probability equals percent of population in that range. Example, area under curve between -1 standard deviation and +1 standard deviation equals probability of -1 smaller than
That z is, probability that z is between -1 and +1. Keep going.
percent of population that lies between -1 standard deviation and +1 standard deviation, which are all about 6 to 8% or 0.68.
Great. So again, one main point, which will come up later, is the area under the curve is the same thing as the probability of z being between two particular z-scores is the same thing as the percentage of population that lies between those two z-scores. So in other words, right, this area under this curve is the same thing as the probability of having a z-score between there and here, whatever the z-score is, which is the same thing as the percent of the population that lies between a z-score there and whatever the z-score is here. So those are all, maybe I should have gone the other direction, shouldn't you guys? Right? Here we go. Right, so between these two z-scores, the probability of the area under this curve between these two is the same thing as the probability that your z-scores between these two numbers is the same as the percent of population that'll have a z-score between these two numbers. Okay, so those are all the same thing. Area of the curve, same thing as probability, same thing as percent of population. They all, when you add them up, better equal what? 1 or 100%. If you add up every population, you better get 100% of the population. If you add up all your probabilities, you better get 100% as well. Okay, so now we're going to talk about applications. You guys all feel comfortable with finding area between two z-scores? No? Yes? Give me a yes or no. Give me thumbs, like yes, no, medium. Okay, good. Now we're just going to add in a layer. If I want to do it for a real problem, I wouldn't say, I wouldn't say, well, you know, hey, George, what's the probability that your z-score is between blah, 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 and blah, blah, blah? He's not going to know. I'd say, what's the probability that you buy an entree and that entree costs between blank and blank, right? It's all about x values. So what we do is we take our x values and we convert them to z-scores. And then we plug the z-scores in with normal CDF, we draw a picture, right, and then we get our probability. So it's just one extra step. First, you take the real stuff, the x values, and you convert them to z-scores. How? You take every value, subtract the mean, figure out how far it is from the mean. Again, it better be positive if it's above the mean, negative if it's below the mean, and then divide by a standard deviation to get it in standard deviations. So that's your z-score. Your value minus the mean divided by a standard deviation. You will need to use that literally in 30 seconds. So if you don't know that, you should write that down now. You should all have it actually memorized, right? A z-score represents, what does a z-score represent, anybody? No one? The number of, right. Anybody else have that down? Just one person? You need to know that for the exam. The number of standard deviations of value is above or below the mean. How many standard deviations of value is away from the mean? Okay, here is our example. This is going to be
An adult has an average 5.2 liters of blood, assume the variable is normally distributed, and has a standard deviation of 0.3. Find the percentage of people who have less than 5.4 liters of blood in their system.
Great. So, first thing I want you guys to do is, I don't know, maybe draw a picture. I think drawing a picture is good. Put in your mean. What's my mean? 5.2. What do I care about? 5.4. I want to know what, less than or greater than, or what with 5.4? Less than. What side's less than? Where's less than? To the right. Left. This side. That's how you get All right, there you go. So left, less than. Now, here's the deal. I can't use regular x values. I have to find z-scores for these guys. So I need to find the z-score for where? For what? This guy right there, because that's the one I need. This z-score over here, do I know that z-score?
No.
Infinity, yeah, negative infinity. So that one I know. This one I don't know. Everybody see where I'm at with this? So I need to find this one. How do I find it? Z equals x minus mu over sigma. So what's my x? 5.4 liters of blood. What's my average? 5.2 liters of blood. What's my standard deviation? 0.3. It's right here. And I will get 0.2 over 0.3, 0.67. That means that the z-score, so these are my x values here. X values. That's this kind of, oops, I should do like that. This stuff here are my x values. Then I'm gonna have another row of my z-scores. That's gonna be here. So then I'm gonna put in his z-score, 0.67. This one, maybe I'll move that one down. Negative infinity. So I need to go from negative infinity to 0.67. So I'll do normal CDF. Negative infinity, we'll go negative 45, that's close enough, comma, 0.67. And if I do that, what do I get? Anyone? Help me out here. Oh, you know what? I don't even worry, don't worry about it. I got it. Magically, I'll get 79.7486. All right, so are you guys okay with this? So here it is. Here's the picture that has the z-scores. And then that's why you do normal CDF of negative, I don't know, 32.67. All right, let me be super clear about this. These are X values. They're your liters of blood in this case, or whatever you have, pounds of garbage in the problem you're going to be having next. These are your z-scores. They are how far you are away from the mean. How many standard deviations you are away from the mean. What's the z-score at the mean, right here? What's the z-score? 0. Because the mean is 0 away from itself. So the z-scores are always centered around 0. The x values are always centered around the mean. Good? Centered around 0, centered around the mean. So you can write both of them, or you can just write the z-scores if you want, or you could just write the x values if you want, depending on the problem. I kind of feel like maybe you should write the both, because it keeps you from getting confused about which one's which. Because what you don't want to do is you don't want to mix and match them. You don't want to take this one and that one. Do you guys understand what I'm saying? Because that causes all sorts of big problems. All right. So here's your thing on applications. Right? Find the area between two x values. Convert your x values to z-scores. Maybe we should do that. Maybe you don't even put them in yet. Convert your x values to z-scores, then draw a picture, and then use normal CDF to find the area between the z-scores. I think I changed this last time. So then don't even put your x values on here. Just convert them to z-scores first and then put them on here. Would that be easier for people? I think it's cleaner. So don't even put your x values on here. Just convert them to z-scores and then draw your picture. That seems better. We'll do that. Let's do that in the next one. So I'll just erase this. Is that better if I erase that? Mm-hmm. Okay. Just put your z-scores there. Okay. You guys need to do lab problem. Flip the page. Lab problem 3. Do it.